Welcome back, and in this video I'm going to explain the stack data structure from the ground up. So we'll start by understanding what a stack is and how it works and why it's useful. And then after that we'll apply it to a classic problem, valid parentheses, the Leetcode easy, where stacks are the perfect tool. So let's start with what a stack is. So a stack is a data structure that follows one simple rule: last in, first out, or LIFO. Last in, first out. So the last thing you put in is the first thing that comes out in a stack. So think of a stack here, like a stack of plates. So let's say this is a stack here, and these lines here are plates. This is a stack of plates right here. And you can only put a plate on the top of the stack and also take a plate from the top of the stack. You can't remove anything from the middle, and you can't access the bottom. You can't take a plate from the bottom or the middle directly. So a stack has two core operations: pushing, which is adding something to the stack, and then popping, which is remove the top element. That's what popping is. You can also peek, look at the top element without removing it. Everything happens at one end only in a stack. So why are stacks useful? So stacks are useful whenever order matters, especially when things need to be undone or matched later. So common use cases are undo and redo, and like editors, for example, that uses a stack data structure. Function calls and programming also use stacks. Expression evaluation, magic parentheses or brackets. The last one is what we'll focus on in our problem here. But stacks are used for a lot of uses. They have a lot of uses everywhere. So now let's move into the Leetcode problem, valid parentheses. So why is valid parentheses a stack problem? So let's look at the look at the problem first. So we're given a string made up of parentheses and brackets, and we need to check if it's valid. So the rules are: every opening bracket must be closed. The closing bracket must be the correct type, and brackets must close in the correct order. So order matters. So the key observation here is the most recent opening bracket must be closed first. This is exactly LIFO, or last in, first out. That's exactly a stack. So let's walk through an example here. Let's say let's go through this example first, right here. So let me just draw an empty stack here. It's our empty stack. And when we see, we'll iterate through the string here. And when we see an opening bracket, we push it onto the stack. So now the stack so you see the first one, push it. The second one is a bracket. And the third one is a parenthesis. So now this is our stack right now. So we push these three, we iterate through the string and push the stack. So this is what the stack contains. And now as we go on, we see the closing brackets here, right? So when we see a closing bracket, we check the top of the stack. So now we've gone through the first three, and now we're going through the last three. So our first closing bracket's what? It's the curly brace, right? So now we see the curly brace and we check what's the top of the stack. The top of the stack is also a curly brace. So they match. So then we pop the curly brace out. So now our stack is just the parenthesis and the square bracket now, because we found a match. And then we repeat, we go on through the string. Second, or the next closing bracket is a square bracket, which is also on the top of our stack. So now we can pop that. Now it's just a parenthesis. And then we hit the last element, which is also a closing parenthesis. So now you push that, And now the stack is empty, which means the string is valid. And now you can return true. So this is a valid case example here. So now let's go through an invalid case example. So right here, for example, we have example 3 here. So let me just draw this out to make it easier. So we have a square bracket, a parenthesis, square bracket, parenthesis. So now we have our stack here. So now we iterate on the first element, push it to the stack. So now we go here. That's on the stack here. And now the second one. And now you can see here, now we're here for we see a closing bracket now. Our square bracket is a closing bracket. Now we see a closing bracket, we check the top. The top is not a square bracket, it's a parenthesis. So there's a mismatch, it's invalid. So as soon as something does not match, we can just stop and just simply return false. So there's also an important edge case here. So if we ever see a closing bracket and the stack is empty, that is also invalid. So that's something to really remember. So that means there was nothing to match it with. So the final stack rule here is at the end, if the stack must be empty at the end. So if there are leftover opening brackets, the string is invalid. So now let me just say the whole algorithm in plain English here. So the algorithm is create an empty stack, loop through the string. If we see an opening bracket, push it. If we see a closing bracket, if the stack is empty, it's invalid. If the top doesn't match, it's also invalid, return false. Otherwise, pop. After the loop, if the stack is empty, that means it was a valid string. And that's it. So now let's translate this logic directly into the code here. So now, let's see. So now we want to define a stack. So the stack list represents your stack. Just a list. And now let's make a dictionary. We need a dictionary called mapping here. So the mapping dictionary tells us which opening brackets match each closing bracket here. So there's only 3 types of brackets we're using in this problem. So it'll just be, we'll have parenthesis, and then we'll have our square brackets. And then we'll have our curly braces. So now, like I said, this will tell us which opening bracket matches each closing bracket. That's the point of this dictionary. And now we loop through every character in the string. So for char in the string s. And now if the character is a closing bracket, so if we hit in the string a closing bracket, if char in mapping, then if the stack is empty, return false. If the top of the stack doesn't match, return false. Otherwise, pop the stack. So if the stack is empty, if not stack, which means if it's empty or stack -1, or that's the top of the stack, does not equal mapping at character. So that also checks if the top of the stack doesn't map the closing parenthesis we're on. Either one, then you can just return false in this case. And if the character is opening bracket, we push it onto the stack. Pop. So now this conditional, like I said, so if the stack is empty, return false. If the stack is empty or the top element in the stack doesn't match the closing bracket, if the top of the stack doesn't match, then we would also return false. Otherwise, we pop the stack. And then now, we have an else statement here. Else, if the character is an opening bracket, then we push it onto the stack. So stack.append character. So if we don't go through any of these conditionals, that means that it'll go to the else, which means it is. So if the character is opening bracket, we push it onto the stack. And then now we can just simply return not stack. So at the end, we return true only if the stack's empty. So that's why we return. So if the stack's empty, if this is true, then that means it was a valid string after this loop. So we can run this. If I didn't make any errors, yep, the test cases should pass. Now we can submit this. And there you go.